Welcome to Chapter 3, Worksheet Part 2. Let's first uncover the atomic structure and complete this table concerning subatomic particles. We have three subatomic particles, proton, neutron, and electron. What are their relative charges? Positive for the proton, no charge for the neutron is neutral, and negative charge for the electron. In regard to their masses, the proton has a mass of 1 AMU. AMU stands for atomic mass unit. Atomic mass unit. Neutron, 1 AMU, and 0 AMU for the electron. For that reason, we say that the mass of the electron is negligible. Therefore, you will find the proton and the neutron in the nucleus, where we find 99.9% of the mass of an atom. And then where do we find the electrons? The electrons are located around the nucleus in the electron cloud. It's good to know some symbols to write down these subatomic particles faster. I will use a small p and a plus for proton, small n and a 0 for neutron because of the neutral charge, and small e and negative sign for the electrons. Okay? Now let's describe the atoms. Two naturally occurring isotopes of gallium are gallium-69 with a mass of 68.99 AMU and gallium-71 with a mass of 71.01 AMU. The atomic weight of gallium is 69.732 AMU. This is this atomic weight, which is an average that you will find here in the box on the periodic table. Okay, this is an average. So gallium do exist as in nature under two forms, the gallium-69 and the gallium-71. And the question is, based on the atomic weight of gallium, which one of these isotopes is found in the greatest natural abundance? Okay, so how will you do this? Well, let's just do a diagram here. So if I look at my diagram, here I have gallium-69 that has a mass of 68.99 AMU. Here I have gallium-71 with a mass of 71.01 AMU. If I calculate the average, okay? So what do I mean by calculating the average? If I have 50% of each, okay? Then I will find the average by doing 68.99 AMU plus 71.01 AMU over 2. If you plug this into your calculator, you get the average being 70.50 AMU. Therefore, if I have 50% of gallium-69 and 50% of gallium-71, if it's a perfect distribution, 50-50, my atomic weight, my average weight, should be 70.50. Well, it's not the case. My average weight, my atomic weight is 69.732. So it's located more likely to the left side in this area. It's smaller than 70.50. For that reason, the gallium-69 has slightly more impact on the average because it's slightly more present. And because the average weight, the atomic weight of gallium is to the left of the 50-50% distribution, the gallium-69 is the isotope that is in the greatest natural abundance. Okay, so there is slightly more, and it's just slightly more because you're very close to the 50-50 distribution. Slightly more 69 gallium than 71 gallium. Problem 3. Silicon has 3 naturally occurring isotopes with the following masses and natural abundance. Calculate the atomic mass of the silicon. So what you need to do here is this is called a weighted average. And I don't think there's a T here. Okay. So you're going to apply each of the percentage to the actual mass of the isotopes. So what do we have? Silicon 28, silicon 29, and silicon 30. You guys need to remember that percent means divided by 100. The 100 being an exact number. It's important we're going to talk about sig figs. So what I will do is time the mass of the silicon 28 by 92.23%. Then I'm going to time the mass of the silicon 29 by 4.67%. And finally, I'm going to time the mass of silicon 30 by 3.10%. So what do I get on my calculator when I do that? For the first one, I get 25.8030949 AMU. That's the contribution with the mass of silicon 28. For the contribution of silicon 29, this is 1.35320255 AMU. And for silicon 30, it is 0.929187.800 AMU. So let's do sig figs for silicon 28. Okay? If you look at silicon 28, it's multiplication and division with 100 being an exact number. I have here 6 sig figs, the 2, the 7, the 9, the 7, the 6, and the 9. I have here 4 sig figs, the 9, the 2, and the 3. The 100 is exact, so it doesn't count towards sig fig. It has an infinite number of sig fig. If I do 6 sig figs by 4 sig figs, 4 sig figs will win because it's the least number of sig figs, and I'm doing multiplication. Therefore, this is what I will keep, the 25.80. Not rounding yet because I'm not done. Let's look at silicon 29 now. I have 6 sig figs here, but only 3 here. 6 sig figs for the mass, 3 sig figs for the percent, so I will only keep 3 sig figs in my answer. And finally, for silicon 30, 6 and 3 again. So 6 sig figs here, 3 sig figs here, the 3 sig figs wins. The leading 0 do not count, so here are my 3 sig figs. To do a weighted average, I will need to add these 3 contributions together. That's how we do a weighted average. But now what I'm doing, and you have to be careful, it's an addition. So when I do an addition, what do I follow? The least decimal places. And if I look, 25.80, 2 decimal, 1.35, 2 decimal, 0.929, 3 decimal. Therefore, when I'm going to be doing my addition, I will input all the numbers, all the digits on my calculator. I get 28.0854853 AMU. But I will only keep 2 decimal places because this is the least amount of decimal places. I am in my answer dropping a 5, so I'm going to need to round up. And therefore, my final answer is 28.09 AMU, being the atomic mass of silicon. You can look at your periodic table to double check that you did a good job. And the periodic table in the box of silicon shows 28.086 AMU. Well, we did a good job. Let's go to the back now. Electrons, a preview. What I want you to do here is to use the periodic table as a guide to complete this table. The first one is the symbol. The symbol, you should know them. Aluminum is Al, nitrogen is capital N, copper is capital C, small u. Okay. The atomic number, you will find the atomic number, which is symbolized by Z, on the periodic table. Okay. So if you look on the periodic table, the atomic number of aluminum is 13, the atomic number of nitrogen is 7, and the atomic number of copper is 29. The mass number A does not figure on the periodic table. For that reason, it's given to you here as being 27 for this isotope of aluminum, 14 for this isotope of nitrogen, and 65 for this isotope of copper. Remember that the atomic number is equal to the number of proton. Therefore, these two columns should be the same, since this is the definition for the atomic number. 13 protons for aluminum, 7 proton for nitrogen, and 29 proton for copper. How do we determine the number of neutrons? Well, you have to remember that the mass of an atom is located in its nucleus. Therefore, the mass number is equal to the number of proton plus the number of neutrons. Okay, since the mass of an atom is located in the nucleus, and in the nucleus we find protons and neutrons. Therefore, it's a simple subtraction here. The number of neutron is equal to the mass number minus the number of proton. And because the number of proton is the atomic number, the number of neutron is equal to A, mass number, minus Z, the atomic number. Therefore, 27 minus 13 equals 14 neutrons for aluminum 27. 14 minus 7 equals 7 neutrons for nitrogen. 65 minus 29 means that we have 36 neutrons for copper 65. Now, if an atom of aluminum is electrically neutral, what does mean that an atom is electrically neutral? This means that the number of proton is equal to the number of electrons because this atom has no charge. Since we are in presence of aluminum, we have 13 proton. Therefore, how many electrons does it have? It needs to have the same number of electrons, and we have therefore 13 electrons. There's a a very easy formula to remember. The net charge of an element is equal to the number of protons minus the number of electrons. It's the difference between proton and electrons. Okay, so let's take a look at B now. We're looking now at nitrogen. Nitrogen has an atomic number of 7, so 7 proton. This time we have 10 electrons. We're looking for the charge. We have an imbalance between proton and electrons. we actually have less proton than electron. Therefore, the difference between the protons minus the electrons is -3, and this is the net charge of this nitrogen ion. C, if the ion of copper, so this time we're looking at copper, so 29 protons is the atomic number of copper is 29. This copper ion has a +2 charge. And we want to know how many electrons, okay? So we're going to write this out. We have 29 protons minus X electron, and this is equal to +2. Therefore, we're going to add on both sides. So what are we going to do? We need to solve for X, which is the number of electrons. And I'm going to add X on both sides. So I get 29 equal 2 plus X. And then I'm going to subtract 2 on both sides. And I get that X equal 27. Therefore, we have 27 electrons. You can always check, okay, 29 minus 27 equal +2. So you did a good job. 5, calculate the overall charge on these atoms ion. So we're going to use the formula that I just talked about because we're looking for the overall charge. Remember that this is the imbalance between proton and electron. This is the number of protons minus the number of electrons. Phosphorus ion with 18 electrons. Because it's phosphorus, you have 15 protons. So 15 minus 18, the net charge is -3. Argon with 18 electrons. Argon has 18 protons. 18 is the atomic number on the periodic table, therefore, argon has no charge. Potassium, atomic number 19 on the periodic table. The difference between 19 and 18 is 1, plus 1 will be the charge. And calcium, atomic number of 20, so 20 proton, 20 minus 18 plus 2. If we're asked to write the symbol for these elements, you will write P for the symbol for phosphorus, and the charge will be written in the top right corner. 3 minus or minus 3 doesn't matter, okay? It's the magnitude and the charge. Then the symbol for this one will simply be AR because we do not write the charge when it's neutral. The symbol for the potassium ion will be K plus or K1 plus if you want, but the 1 can be omitted. And then the symbol for calcium will be, the calcium ion will be Ca and then 2 plus. Again, if you want to write Ca plus 2, it's okay. Or if you want to write P minus 3, it's okay, but it has to be in the top right corner. This is the location of the magnitude of the charge. Write the complete isotope symbol for the following atoms or ions, including the element symbol. So let's do this. We have electrons, we have a complete, we have the neutrons, and we have the protons. Remember that the protons give us the atomic number. Atomic number 37, this is rubidium, Rb. 16 proton, atomic number 16, look at your periodic table, this is sulfur. Atomic number 82, look at your periodic table, this is lead, Pb. Okay, one information. Second information, we need the mass number. The mass number, mass is located in the nucleus, is the number of proton plus number of neutron. 37 plus 50, 87. 16 plus 17, 33. 82 plus 125, 207. Then to find the net charge, we're going to look at protons and electrons. Remember that the net charge is the number of protons minus the number of electrons. 37 minus 37, no charge for rubidium. You can omit the 0 if you want. 16 minus 18, 2 negative for the sulfur ion. 82 minus 78, positive 4 for the lead ion. Now, because we are looking for the complete isotope symbol, do not forget that in a complete symbol, the atomic number should be written in the bottom left corner. 37 here, 16 here, and 82 here. And now you have the 3 complete isotope symbol for these elements. Thank you, and good luck with everything. Keep working hard.